And if it's okay with, I guess with Steve and Scott, since we're the first few people to talk, I'm going to go ahead and get started. Welcome, everybody. My name is Matt Hardy. I'm the Program Director for Planning and Policy here at AASHTO. At AASHTO, I am the liaison for a number of committees, including planning, performance management, and then asset management. And one of the most active ones, I guess, from a webinar perspective almost, is our subcommittee on asset management, where we've hosted a number of webinars over the past 1 to 2 years. So welcome to this webinar, Know the Risks, GeoTechnical Assets as a Key to Improving Performance. This one is sponsored by both the FHWA Office of Asset Management and the AASHTO Subcommittee on Asset Management. Some housekeeping issues just for those who have recently joined us. I've put us into what we call lecture mode, so this automatically mutes everybody's phone through the conference call system. If you could please keep your phone muted, I would appreciate that. That helps with people putting us on hold and us hearing that beautiful music in the background where we can't hear anybody else. And for those that are, walking and traveling and everything and all the sort of noisy background stuff, it sort of eliminates those issues. So if you could do that, that would be great. Just so, again, so everybody knows, we are recording this webinar. In the next week or so, as we process the actual video and get it uploaded, you'll be able to download it, or not to download it, but to actually go see it, review it, on the Subcommittee on Asset Management's website, and that's at tam.transportation.org. The one other thing that I want to mention before turning it over to Steve Gay from FHWA is that AASHTO and FHWA have a great, I think, sort of relationship going where we are sponsoring a number of webinars. The one that there are two currently ongoing. One is a bi-monthly webinar series on the general topic of transportation asset management. Our most recent one was last Wednesday, and these take place the second Wednesday of the month, and they happen every other month. So our next one is going to be July 10th. I forget the exact topic, but you can sign up for those webinars at tam.transportation.org. So that's a series of webinars on various topics related to asset management. The one last week was on risk and asset management. We've also had one on safety and asset management, sort of business processes and asset management. And I think I know in the coming months we're going to have one on performance management and asset management, and then planning and asset management. So a lot of good topics upcoming. The other webinar series that is ongoing is what we call the Book of the Month, and the Book of the Year, actually, happening over about 9 or 10 different months, is on the AASHTO Transportation Asset Management Guide, a focus on implementation. That sort of book club meets once a month, and they basically go over or review each of the chapters in order from the AASHTO Implementation Guide. And if you want more information about signing up for that, you can go over to FHWA's Office of Asset Management website. So with that, I'm going to turn it over to Steve Gay from the FHWA Office of Asset Management. Steve.
Thanks there, Matt. The Federal Highway Administration is pleased to present this webinar in cooperation with AASHTO. The topic of asset management and geotech assets received a lot of good attention and went very well last year at the National Asset Management Conference in San Diego. And I think it's particularly important to consider geotech assets, realizing the requirements of MAP 21, where each state is required to develop a risk-based asset management plan for the NHS to improve or preserve the condition of the assets and the performance of the system. As the states develop their asset management plans, they must address the pavements and bridges on the NHS, but they certainly should consider where the geotech assets fit into the scenario. We often hear in the news of some event happening, be it related to extreme weather or other factors. This is an important area. You see the agenda up on the screen with presentations with Scott from Federal Highway, Dave Stanley from Alaska DOT, which are very active in the geotech area, Mark Vessely from Shannon and Wilson, and Tom Badger from Washington DOT. And as we are developing this webinar series, in order to cover it all, another webinar is scheduled for next month where we have presentations from Federal Highway, Federal Lands, along with Colorado DOT and 10 fishermen from McMahon and Mann. So the learning objectives of today's webinar are to develop an understanding of the role of geotech assets in the performance of the system. I think that photo you saw right in the beginning here says an awful lot. Next is learn how to consider risk and implement asset management plans designed to improve performance. You're going to have some case study presentations and learn what a couple of state DOTs and federal highway agencies are doing to manage their geotech assets. Once again, it's a great pleasure to present this webinar today, and let me turn it over to Scott Anderson from the Federal Highway Administration.
Hey, good morning and good afternoon. This is Scott Anderson, and can you all hear me fine? I assume so, but
Yep, we can hear you, Scott.
very good, Matt. Thanks. Pleased to be here today to share this information with you, and I thank you all for attending as well. The MAP 21 legislation that Steve alluded to, and Matt too, is a good place to start. It does emphasize the, take me to the next slide there, Matt. It does emphasize the both the performance and the risk aspects of what we're here to talk about today and also again next month. It's important to note that some of the work that we'll present in these talks today and next month really predate the earliest drafts of any MAP 21 legislation. They've been going on for some time. And none of the ideas that we're talking about here today are actually required by MAP 21, as Steve mentioned there. But all of the work here is endorsed by the evolution and practice, if you will, that's represented by the new legislation. After all, the legislation doesn't lead. It just solidifies things a bit. Section 1106 of the National Highway, back me up there a second, there we are. Section 1106 of the Highway, National Highway, of the bill is the National Highway Performance Program, and it's where the risk-based asset management plan is required. It's stated to be required. Section 1203 is where the goals are set, and this is where you'll find that pavement and bridge standards and measures are referred to as a way of measuring our progress towards the goals. Next, Matt. And we've been doing this a while with pavement and bridges. You could argue for a while about whether these are good measures, but we've been reporting, this is an old DOT report to Congress about conditions of these types of assets for some time. It's really a good thing the legislation didn't require something of GeoTechnical because other than perhaps the design factor of safety, we don't have any standards and metrics that we could be working towards. Next slide, please. I think it's also important to look at a little historical perspective of how we got here. Not all of these things came from the same place. And if you look historically, back it was in 68, following the Silver Bridge failure in 67, that there was the National Bridge Inventory established. It was based on, to solve a safety issue first. I mean, to ensure that we have safe bridges for the public. As about 20 years later, ICE-T in 91 was first pavement management, and that was a fiscal responsibility, recognizing that there's a lot of money going into pavements and that we need to be especially careful in managing such a big dollar item. 20 years later or so again, here we are at MAP 21, and we're defining performance now. And performance is multifaceted. There are many goals. So what's the intent here? Next slide, please. This is Congress's language with my emphasis added. And if you just look at the emphasized words, you can see that Congress has in mind a system of safe, efficient, and reliable, a safe, efficient, reliable system that helps for movements, its mobility, its flow, its movements, and so on. The performance goals relate to this intent. Next slide. performance causes these goals not to be met. The bridge and pavement measures can't do it all. Next. Matt, next slide. There we go. Whoop. That's good. I want to do these one at a time. This is a viaduct in Colorado on I-70, which actually might have been in fine standing on the National Bridge Inventory until this rock hit, and now it's certainly not. Next slide. And this is I-40 in North Carolina. Again, pavement here might have been in fine condition until this rock slide came down. Both these corridors now are impassable, and that's clearly a pretty poor performance. Next slide. This is an entire embankment section lost on, I believe it's 441 in North Carolina at the Great Smoky Mountains, and it actually provided access for that the Tennessee towns that really thrive on the livelihood that the tourism industry brings there. Entire section lost. Next slide. Here's a tunnel that was discovered in Colorado just between Vail and Leadville in the peak tourist season. It fortunately daylighted just outside of the pavement section there, you can see, but it goes right underneath the pavement, unknown until it surfaced. Next slide. And here's a retaining wall that's in between US 6 on the left and I-70 up on the above the wall that wasn't maintained or managed until it became such an issue that it required a $10 million repair that actually impacted both highways. Next slide. And this slide here from Taiwan a couple years ago maybe says it best. You've got tunnels at the very top of the pictures, plenty of bridge structures, embankments, other kinds of earthwork, and pavement in between, and really it's quite clear that this is not a viable transportation corridor. Next slide. So the thesis that we're presenting here today by my talk and those that follow is that systems for safe and efficient, reliable mobility are made up from corridors, and the corridors are kind of a special asset because it's the management of a corridor that could ensure that the goals of MAP 21 are met. It could ensure that we have this mobile system. Other assets can't quite get us there, so maybe it's a higher level asset, or you can call it what you will, but that's the idea. Systems are made up from these corridors as components. An example from Wyoming is shown. Next slide. So corridors are like chains. Each link is an asset, or maybe it could be called a feature or something like that. And, of course, when a corridor crosses a valley or a ravine, it's crossed by a bridge structure, and in between it's got pavement types from A to B and B to C and so on. But corridors also cross mountains, and they cross them using cuts, and they using fills and using retaining walls. And corridors also cross geohazards like sinkholes and abandoned mines, and swelling soils and collapsible soils. So corridors have a lot of different links to them, and corridors break like chains do as well. Next slide. So just a couple examples to show what we've learned about really where the costs are here. This is a I-70 again in Colorado. You've seen that upper picture, but the point on this slide really is that I-70 in Colorado closes every few years because of a geotechnical or let me just say a different way, because of a non-pavement, non-bridge asset problem, and it closes the highway. And CDOT estimates it costs about $800,000 a day to close the interstate, and that's what's happening there. Next slide. In 2009 rock slide on I-40 North Carolina, you've seen this photo as well. A little bit more in-depth study in terms of the cost was done for this slide, and basically it works out to be about $1 million a day, even though this one has a lower ADT than I-70 in Colorado. So the failures are dramatic. They look like there'd be big safety issues, and when there are safety issues, they're tragic. But really the big deal is the cost of closing the system. And $1 million a day for an interstate geotechnical issues that are about related to inventories and definitions, forecasts and models, expectations for standards and measures, and we're going to learn from some experiences. We really have a lot we need to do. If you think about pavement, for example, most states have one or more of these type of pavement deterioration curves that they use to manage their pavements. Next slide. We don't know, for example, if when we're looking at slopes, whether we have the same type of a curve. Do we have it for all slopes? Do we have it for some slopes, some geologic settings, some climates, some aspects, etc.? Next slide. It may actually be that in predicting slope performance that the impact of natural events makes it a pretty noisy curve. It might have the same trend, but it might be hard to see the impacts of preservation activities in this type of relationship. This is what we need to learn. Next slide. It could actually be that extreme rare events really have a dominant influence on the way some of our geotechnical features perform, and that's also something we need to discover. In this case, we're really looking at the risk that is introduced by, you can easy to picture it in terms of an earthquake or something like that. A recurrence interval type risk management approach is what would be required. Next slide, please. This is my final example here. This is US 2 in Crookston, Minnesota, where the geotech folks are doing a great job with the DOT, and they actually noticed an issue here and came out and instrumented this site just 4 months before they lost the entire road, well, not the entire, but the one direction of US 2. And, the question is, using a risk-based approach and then maybe a Tier 1 inspection of this alignment, could one have foreseen problems here and put some attention towards looking at it sooner than, more than 4 months in advance? You see it's on the outside bend of the river and so on, and these are the kinds of questions we'll be pursuing. So next slide. So what I want to leave you with today is some points to carry forward and some ideas that you can think of as we go through these following presentations and so on. Corridors are built from links of a chain, and they are the real asset of a state highway agency or someone else who owns roadway systems. Geotechnical features are links in this corridor, and the system that the owner has is built from a series of these corridors. And another important point here is that some corridors have priority. This is important because one of the challenges we have looking at management of geotechnical assets is the time-consuming business of getting inventory and condition assessment on these features, which heretofore haven't really been managed. And using the priority of corridor approach, one can start to do meaningful inventory and assessment work in a logical and risk-based way. So that's an important outcome here. Indirect costs are the prime geotechnical impact. Despite the dramatic look of some of these things, really the issue is closing down the roads and impacting the environment that we're in. And finally, I'll leave you with the idea that we need inventory assessment and prediction developments, and that's what I really see as an important and exciting part of the geotechnical engineering future. Next. Great. Thank you very much. And Matt, I think we're going to do questions only at the end here. So.
Correct. Yeah. So I think now next up is Dave Stanley from the Alaska Department of Transportation. Let me go ahead.
I will mute and turn it over to Dave.
All right.
This line is now unmuted.
So Dave, you should be up.
Okay, can everybody hear me?
We can hear you.
Okay, thank you, and hello to everyone. First, I want to give a quick thank you to Steve and everybody at the Office of Asset Management and to Matt Hardy for putting this on and for their continuing encouragement of development of asset management for geotech assets. and also to Scott Anderson for his inspiration to me. So today, next slide, please. So today I'm going to talk about several topics. I want to discuss a bit of not getting beyond introducing GAM towards implementing GAM principles and best practices for our agencies that work in transportation. I'll be talking about a roadmap for this development and a few key events in the process for implementing GAM. And I'll talk about these key processes, inventory and condition state descriptions, Scott alluded to a minute ago, condition indices, levels of service, and performance measures for managing these kinds of assets. And then at the end, I'll talk a little bit about cost analysis. Next one, please. So this is what a roadmap could look like for GAM. And it's a simplified version, but you can see there's a whole series of steps that we will probably have to go through. And I should note that, as Scott mentioned, many of these kinds of GAM programs have been around for years and years. One great example is WSDOT's unstable slope management system that Tom Badger will talk about here in a little bit. But these predate TAM in many cases and certainly GAM. So let's just move on to the next slide. I'll talk about some of these key points. This is a little busy slide, but these key issues, first of all, I think many of us are going to have to advocate to get a seat at the table with TAM. And that's what's been going on with this group for the last couple of years is exploring what the role of GAM is and how to get moving forward. And you may have to actually create a role for GAM in your agency. But keep in mind it should not be a separate silo, but kind of integrated with the TAM development process. And how do you start? Well, you can start by doing some research, and I think the best place to start is with the TAM guides that Matt mentioned earlier. And these are easy to find. You shouldn't have any trouble getting to those. And as you move along, probably the very first step you want to do is look at the 5 core questions for asset management that you can find in these guides. The first one of these is, what's the current state of your physical assets? Where are you with locating these important assets and knowing the condition of them? Then you're going to want to know about what is the required level of service for these assets? What is it you want them to do? You can define this in pretty simple terms. For retaining walls, it's not too hard to think about what you want a retaining wall to do. Then you have to think about which assets are going to be critical to sustaining the performance of these corridors that Scott just talked about. We're not going to look at every asset that we can. We're not going to make decisions in corridors based on sign reflectivity, for instance. But we need to find out which ones of these assets are critical. And then 2 final core questions are, one is tactical and one is strategic. What's the best investment strategy for operations and maintenance and replacement? And then finally, what's the best long-term funding strategy? And that's really a question for the TAM development process, but GeoTech should be in the mix in that question. So then the next step, of course, is learning the characteristics of your assets, and this is the inventory stuff. Identifying what kind of performance gaps you have for these assets. Do you have a whole class of retaining walls that aren't working the way you want them to, and so forth? And then, that segues into risk, and you need to identify risk areas for these assets. And this can be low-level, asset level, and it can be all the way up through the agency decision-making tree. And then, again, as I mentioned before, cost analysis is going to be very important, and we're not very far along in understanding how to do that for geotechnical assets. And the whole point of all this is decision support. So we need to come up with procedures to incorporate geotechnical assets in that process. Next slide, please. So here's an example of a geotechnical asset. These retaining walls in Alaska, we don't even know where they are, much less what condition they're in. So we've started a retaining wall program, and we're going to start off with inventorying them. But how do you assess the condition of this wall? Obviously, the colorful part was built first, and then all this other crap was added on top. So what's the current condition of this wall? What's the service level that we're going to expect with it? Now, based on its current condition. And, how much life does it have left? When are we going to program a replacement? These are all the kinds of questions you need to ask about many different kinds of geotechnical assets. Next slide, please. So these are key features here: levels of service, condition indices, and performance measures. Well, what are these things? Levels of service, and again, this is, can be easily found in the TAM guides. Levels of service are targets that the agency uses to describe a desired level of functionality. And this can be, some kind of maintenance and operations condition that you want to keep track of. And the next step is condition indices. It's basically a numerical scale that's applied to an asset condition. And often these conditions are based on observations, sometimes measurements, but often just on observations. Examples of those: pavement roughness index, bridge condition, national bridge inventory, and unstable ratings, or unstable slope ratings for both risk and hazard. And the last one is the performance measures. And what these do is represent how well an asset, or perhaps a grouping of assets in a corridor, are behaving, and whether the asset or corridor functionality is meeting the expectations of the agency and its customers and stakeholders. Next slide. This is an example of a level of service, and this is Alaska DOT winter road maintenance levels. So the top one is the highest level, the best level, and it basically describes removing snow continuously during storms and keeping a lane open in each direction. And that can be pretty tricky in all of our snow states doing that kind of operations. And then for lower level roads, here near the bottom, we've got some roads that could be impassable for extended periods during a storm. But they still have a goal, and in this case it's 72 hours, that the road should be returned to fair driving condition. So we've attached some numbers to this. Next slide. All right, now this is a grouping of condition indices, and this illustrates the point that all these kinds of indices can be equated to one another if they have a numeric scale. It doesn't matter whether it's 0 to 9 like the bridge or 0 to 100 like pavement. You can put them all together. And you can make a simpler scale. You could even make it a 3-part scale, or red, green, yellow, good, fair, poor. And probably in the beginning of this process for geotech assets, simpler might be better. Next, please. So performance measures. Here we've attached, for rock slopes, levels of service and related those to a performance measure for that. These are simplified, but if you look at the top one, it's road closures due to rockfall or landslide incidents. And we can track that if we have a good relationship with our M&O people, and have a requirement to keep the limit, or to limit the number of closures to 3 a year per district. And we can track that and see how our maintenance forces are performing. And at the bottom, it can be a little bit different kind. Level of service is just smooth roads. And we can check that with our IRI rating and pick a level that we want to meet. So performance management, as a process, there's a couple of key features. Data is just the most important thing to start off right at the beginning. We want to make sure we get the right data, the right people at the right time. And that's probably going to require an enterprise data system for most agencies. And that doesn't mean one giant database. What it means is one location where everyone can go. And in Alaska, we're creating data web pages that have links to other databases. And I think that's a system that a lot of agencies could follow and already have done. Again, we're going to only look at these essential assets. We don't need to talk about sign reflectivity in this kind of system. And I want to also make a point that all of the purpose of all this is to integrate all these things, the last things I talked about, service levels, condition indices, and these performance measures, so that we understand and assure that we're getting a performance of our corridor the way we want it. Okay, next please. And this is an illustration of how we can aggregate these things. And if we go from right to left in this, see on the right, the orange stuff is their performance measures for different kinds of asset classes. and whether it's retaining walls or unstable slopes. And then we use the performance measures to create condition indices, which I'll just call a health index, or like in material sites, it would say material site sufficiency index. Doesn't really matter what we call it. The idea is you aggregate all these things together and weight them appropriately to get an overall rating for the corridor. Now this represents only geotechnical assets, but you can also add in other kinds of assets like bridges and pavements. Next, please. Okay, this is a flexible rockfall barrier, and just using this to introduce the topic of hazard and risk. And Mark Vessely will be talking about this in a few minutes. And this is a fairly short barrier that's located in a very specific area of a pretty lengthy rock slope. And obviously there's a reason they built this thing here, but this kind of illustrates that not all geotechnical assets are made of rock and soil. This is steel and concrete. There's wire mesh and cables and all kinds of elements here. And it's an adjunct, really, to the larger geotechnical asset, which is the slope. But why is it here? And next slide. Well, this is why it's here, because there's a whole bunch of more or less stationary assets at the bottom of the slope. Railroad tracks, there's a tourist train that stops there. This is the dock ends at the end of the picture down there, so nobody is going through here at a high rate of speed. And that kind of illustrates the point that location makes a difference. What's the setting? Is it urban? Is it rural? Is there high ADT or low? All of these things are important, and we've got to develop a framework to incorporate all those things into a GAM program and a TAM program. And Mark Vessely is doing some research, Shannon Wilson, for incorporating risk management into our geotechnical asset management program, which is also under development, and we can talk about that another time. Next slide, please. So now we're getting to the last topic, which is cost analysis for GAM. And again, the goal is to support decision making. So how do we do that? We have to understand the life cycle of our assets, because if we don't know that, then we can't put life cycle costs on it. And we're in a bit of a pickle right now with geotech assets because we just don't understand very well some of these assets in the life cycle. We have a lot of sort of intuitive knowledge, but we haven't really put numbers to a lot of these things, and that kind of research is underway. So bottom line is we have to have that understanding. We have to be able to put numbers on it. We have to be able to put dollars on it so that we can participate in the decision-making process. Next slide, please. And a little bit simpler than the life cycle cost, if we look at this as the good time series showing cost and benefits, and with the black is the cost and the blue is the benefits. And it's pretty clear how this time series kind of thing can work. We have your initial capital cost, and then periodic annual costs for maintaining things, and then as time goes by, you get like a 4 or 5 year period where you're going to have to do some preservation to keep the asset working. And we have to be able to understand what this is. And I think a great example of this that Tom Badger will talk about is for his unstable slope management program, where they actually do this benefit cost analysis to determine what projects are going to build. Okay, next slide, please. And this comes to the end now. We need to apply these geotech principles and all the related management disciplines of TAM, performance management, and risk management to geotechnical assets. And we've done a great job in the last couple of years in raising awareness on geotechnical assets, but we need to keep weight forward to continue developing these principles. And it does require a change in culture for most agencies. They don't really consider geotech assets. And they're, we all know that bridge and pavement are going to come first with MAP 21, but geotech is not far behind. So the takeaway is just get a start. There are lots of steps here, but make an effort to decide which assets are important, set up a data collection program, and start collecting inventory and condition data for these important assets. And as time goes by, we'll get better and better. Thank you for your attention.
All right. Thanks, Dave. Up next is Mark Mark Vessely. Let me bring up his presentation.
Matt, are you hearing me?
I am.
Great.
Hang on, hang on 1 second. Do you see something now, Mark?
Yeah, I'm ready.
Okay. Is the presentation on the screen there?
Yeah.
Okay.
All right. Well, thanks, Matt. So I'm here today to talk about how we can use risk-based methods to identify and manage some of these geotechnical features that we're here talking about, whether or not it's for a transportation owner or an agency. You know, Scott and Dave both talked. Some of these photos here even show, things like rockfall sites and barriers, pavement damage from unstable subgrades, landslides, things like that. And so, as we go to the next slide here, what are our geotechnical assets? And, this is an interstate here in Colorado. We have the interstate highway up on the top of the embankment. We also have the U.S. and state highway down below. And within this, this slide does a pretty good job of capturing the range and assets that might exist within a corridor, and they just happen to all show up here in one location. We have constructed embankments. We have historical landslides, new landslides, retaining walls, culverts, rock falls, several different types of features. And I don't want to say that this is the exhaustive list, but these are some of the types of geotechnical features or assets that we might consider. Moving on to the next slide, though. Now, if we look at this with more of a performance context, we can see the role that the performance of these assets has. Scott mentioned Interstate 70 has roughly 40,000 cars and trucks a day, almost $1 million in economic value. We obviously have the traveler and worker safety for folks on the roadway. We have commuter routes, a lot of recreation in this area, fishing, and so those geotechnical assets all contribute to the ability for these to happen. And additionally, in this situation, even the DOT isn't necessarily the only property owner, so any negative performance can impact the U.S. Forest Service or railroad interests in the area. So we go to the next slide here. This is the photo Scott showed, and this was a retaining wall that's within that slide. It's the middle bin wall. And that wall was in this condition for several years. Unfortunately, there wasn't really any project in the area that could have addressed this. And as time went on, the wall never failed. So if we think about the condition curve, it was relatively flat. It wasn't really changing. They measured it. It didn't move much until the next slide, which is in 2008, a little higher year precipitation that year. But nothing, too off the charts, and the wall does fail, and it fails suddenly. So in this case, the condition curve is almost more of a right angle downward. By doing this, the wall destabilized the constructed embankment above it, triggered a bunch of landsliding that eventually grew to threaten the interstate. And as our next slide shows, the DOT ended up expending over $10 million to fix this. They closed the lower state highway for several months. There was environmental damage from stormwater and mud runoff. Also, this is in an area where the DOT is trying to work with their stakeholders as far as improvements, and having buy-in from those stakeholders can be a challenge if you're having to take care of these. So moving on to the next slide. So as we decide what are the geotechnical assets we want to manage, it's from our perspective, it's more important to focus less on the definition of what an asset may be, but rather consider the contribution to performance. These slides, the lower left shows a sinkhole on I-70 that closed the highway for about a day and required $500,000 to fix. The middle photo there shows the Ferguson slide, which blocked for several weeks the main access into Yosemite. The far right shows the Beartooth Highway, which was impacted by debris flows and was shut down for almost an entire tourist season. So
Obviously, there's some major mobility and safety impacts. There's the reputation, environmental. Obviously, just to fix these, if you take out the economic cost, is pretty substantial. And I think when you put the repair costs with the economic costs together, these costs can be several orders of magnitude greater than many of the other assets that we are already managing in transportation asset management. So moving on to the next slide. As Dave mentioned, it's important that as we do this analysis to distinguish between hazard and risk. And when we talk risk, it's a formal definition where we're evaluating the likelihood and the consequence. And so this photo shows a high rockfall hazard site, but the risk is really related to the degree of exposure, which can vary depending on the amount of traffic in the area, maybe even where you're on the road, the speed limit. And it's even further compounded by the fact that there's a Bureau of Reclamation dam and spillway right next door, so on the right side of the photo. So those are all contributors to the risk evaluation we need to do. Next slide, please. Now that last slide shows one specific site or project, but what needs to be recognized is how risk can propagate through an organization. While that individual rockfall site may have a fixed mitigation cost or an engineering and maintenance need, it also presents a financial risk to the corridor or the management program, and often in an unplanned nature. Additionally, as we mentioned before, there's political or reputation impacts if the DOT is viewed by their stakeholders as not able to maintain the roads in an acceptable condition. So as we do these risk analyses, we need to recognize that that risk is going to be observed and measured differently throughout the organization. Next slide, please. Now, as we look at doing this risk assessment, it's important that we do it in the context of the agency performance goals. The slide there on the left is a landslide. These two sites, the two pictures in this slide are roughly a mile apart, and the landslides in this area oftentimes will happen on the order of maybe 10 to 20 years. They might remove the road from service for a couple weeks at a time. So there's obviously some significant mobility costs, mobility impacts and repair costs, but the safety risk might be relatively low. However, if we're concerned about safety, the rockfall site, those failures and incidents can happen routinely on an annual basis. The repair costs actually might be relatively lower, but the safety risk is obviously higher. So moving on to the proposed approach for this, as Scott and David both referenced, there's a lot of features out there that we can consider, and from our perspective, it's important that we group things into a geotechnical class, and this allows us, not all walls, not all rockfall sites and everything, like landslides, are going to have the same level of risk. And so by using risk, we can focus on the assets that are most critical to performance. And to take that to the next step, that's where we need these well-defined performance measures so that we can perform this risk analysis in the proper framework. Next, please. So if we go back to this introductory slide here, in this situation, on the lower right there's a rockfall site and a culvert, and at the time of this event, these were the two features that were managed within the DOT. However, neither one of them contributed to the need for the $10 million repair or the retaining wall failure. And so this is where, by grouping features into a geotechnical class and evaluating the corridor or a section of highway for the features that generate the highest risk is important, because as this slide shows, just because we manage something, the reduction in risk that can occur might be incomplete if we leave something out. So it's important to consider everything, and a geotechnical asset class is the way we can do that. Next, please. So why do we want to talk about, why do we want to do risk-based analysis? First, it's part of the TAM process to begin with, and I think what we're proposing here is that this moves the risk-based approach a little further up in the steps within a transportation asset management plan, and it allows us to maybe gain some efficiencies in the inventory and the assessment. Also, as we've heard already today, there's a lot of uncertainty with Earth systems. We might not even know what we have, and so the uncertainty, the variability, risk is a well-established tool that we can adapt from other industries and market sectors to our benefit. So moving on to the approach, initially we might want to start with an initial qualitative assessment, and this can maybe be a little simpler. Again, this is to capture some efficiencies. Maybe instead of inventorying all retaining walls to the same level of detail, maybe we want to focus just on the type of feature, maybe where it is, establish some sort of relative condition, almost maybe a 1 through 5 scale. And then this is where we want to bring in our consequence and failure scenarios. And again, we're doing this in more of a qualitative basis. Now the next slide shows what a consequence evaluation might look like. And it's important here is what we're trying to do is capture the propagation that this risk has through the agency. So whether or not we're looking at mobility and safety, or just the physical costs, or even some of the more reputation or higher level or management level risks that might be perceived. And we're just really trying to capture a relative ranking here, 1 through 5. Next, please. And we can also do this with the likelihood or the probability assessment. Again, we're just trying to capture in a relatively efficient and rapid manner, if we're looking at a geotechnical feature to screen it, is this something that happens once or twice a year, or is this something that maybe only happens once in everyone's career, or even greater like that? Next, please. So as we go through this process, we can have a whole stream of different features, walls, embankments, landslides, all of that, and we can do this initial qualitative screening, and this is where our performance measures come into play. And so for the DOT or the owner that's concerned or has a certain safety metric that they want to target, we can perform the screening looking at maybe the features that present the greatest or the highest risk level, and that would be the red areas that we see down there in the lower right. However, as the next slide shows, we can also look at this from a financial standpoint, and we can do these both. It's not one or the other. We can be looking at safety and finance or financial impacts when we do this analysis, because it's important to recognize that some sites might have relatively low or remote risks, a safety risk, but they can also have some pretty significant financial, and that's where the agency or the owner's performance measures come into play. Next, please. As we continue this analysis and say we're within a geotechnical asset class, and this is an example where maybe you have a landslide, a culvert, a wall, and a rockfall site, now we can start going through some management scenarios of, ranging from maybe no improvement to different levels of mitigation and maintenance. And we can look at estimate the relative success of those, the costs that would be associated both for the initial action and the life cycle to do some of what Dave's slides talked about, where we're looking at the life cycle analysis as a means to guide the management, the geotechnical asset management plan. Next, please. Finally, as we pull all this together, again, we really want to be focusing on the agency or the owner's transportation asset management plan or their goals. And so some of those goals might be, the bigger issues such as safety and mobility, and there's performance measures that may exist or are being established within those different goals. And so if the agency has a goal to work towards 0 fatalities per vehicle mile traveled, then we can do the risk-based analysis. We can identify the sites that establish the highest risk, and then we can look at management scenarios to help meet that agency transportation asset management goal. Same thing with closure. Scott mentioned I-70 in Colorado. It has a pretty good history of being closed for a couple days at a time. And so if the goal is to reduce those hours of closure, we can look at the geotechnical assets or the geotechnical features that may present the greatest risk of something like that happening. Next. As we wrap up again, I think there's a pretty good database on risk-based practices from other industries and agencies, and so we can use these practices to efficiently identify and manage the geotechnical features, many of which we're talking about today. And as Dave indicates, the time, there's no reason to wait. There's a cost of inaction. And as we were doing some work for Federal Lands Highway, I came across some studies that indicated in the United Kingdom they were able to document 60 to 80% savings over the life cycle of railroad and motorway embankments when they were doing asset management. And at first when we saw that statistic, we thought that maybe there was a little bit of bias or it was a little inflated, but I think if you go back to that initial slide with the retaining wall that led to $10 million fix, it's easy to see how that could be a very likely possibility. So with that, that does it. Thank you.
All right, thanks, Mark. And we will take questions at the end. And the way I like to do this is through the Q&A feature through the Microsoft Live meeting. So at the top of your screen on like a gray bar, you should see Q&A. And if you just want to type in your questions there at the very end, I'll be the moderator and we'll get to them. So up next we have Tom Badger. Let me get your presentation here. Are you on, Tom?
I'm here. Can you hear me?
I can. Let me, can you see that?
Not yet.
Oops, no. How about now?
Yep.
Okay.
A little striped, but I can work with that.
Okay.
Okay. Well, good afternoon, good morning for those of you still on West Coast time. I guess before I get started, I just wanted to acknowledge my predecessor, Steve Lowell, and Pat Morin, who conceived and developed and implemented the program that I'm going to speak about. So here in Washington, we are fortunate, I suppose, to have an abundance of slope hazards that create lots of problems or impacts on our highways, and these would include landslides, rockfall, debris flows, erosion problems, and the like. So the presentation here is just to revisit some of the experience that we've had over the last 20 years of implementing this program, some of the lessons learned in Washington State. Next. I would start by saying that prior to 1995, when we implemented this program, we pretty much had a reactive management approach to unstable slopes. Next. So in 95 was sort of a watershed time in our agency. The development of the unstable slope system was kind of a new part of a new project programming approach. It was implemented in our agency for the highway construction program. The approach involved prioritizing and programming projects based on the extent to which they addressed highway deficiencies. So unstable slopes was one of those identified as a deficient area, and that was included in our preservation program. And there was an estimate made very preliminarily that the funding needs for that, if we're going to assume a 20-year program life, might be on the order of about $300 million. So a substantial amount of money just to get this going and to commit to. The parts of the program was that we, unlike a lot of rock slope management programs that have been implemented across the country and elsewhere, we were going to consider all slope type problems that impacted our highways, so landslides, debris flows, settlement problems. And if I could sort of craft a mission statement around that, the idea was to rationally evaluate known unstable slopes. So we're not going out to look for new problems. We have plenty of existing ones, and to try and proactively address these deficiencies. So there's sort of four main management activities that were implemented beginning in '93 to get this going. First was to develop an inventory. So you're looking at here a GIS map of a number of sites around the state. We have about 3,000 or so unstable slopes that fall into those 4 or 5 types of slope hazards. Next one. So after we developed that initial inventory, there was a big effort to do detailed ranking. So this is our data sheet that we use to develop a hazard/risk ranking, and there's, I don't know, I think 10 or 11 criteria that we look at, and some fields are sort of more risk-based. There's 1 or 2 that are more hazard-based, and that gets us basically a number, a hazard rating or a risk rating number. Next. Next slide. Are you there, Matt?
Yeah, or is it not coming? I've got things switching on my end.
Not for me. Okay, so you have, I'll just work off this other one then.
It's project scoping.
Yeah, okay, let me get there. Okay, so project scoping. So the next part of this was if we were going to try and come up with, to build a program of slopes that we were going to mitigate, was we need some cost estimating of those. And so we used these risk-based numbers, these rating numbers, to glean off higher rated slopes, and we did detailed scoping on these by our GeoTechnical folks, and this was looking at identifying, rough costs for mitigation, whether it was drapery systems or buttresses or drains and the like, and those cost estimates were used then for the next phase. Next slide, please. Which is the activity of prioritizing slopes. So we have 300 or 3,000 slopes. We need to come to some logical basis to develop that prioritized list for our highway construction program. So there's couple activities around that. So the next slide. We implemented with this a benefit cost analysis that considers a delay cost, and we assumed for any slope that we would be looking at, say a 24-hour closure, we were going to add those costs to the maintenance costs for what it was to maintain the unstable slope problems associated with that, and then balance those costs against what it would cost to fully mitigate the problem. And those costs to mitigate were less than these delay and maintenance costs, then we would achieve a favorable benefit cost ratio, and that allowed a slope to advance for future programming. Now, we do consider on certain site-specific projects where we could do more detailed benefit cost analysis. This is a very simplified one. But one of the things that we recognized here is that you could imagine that lower cost fixes are going to quickly rise to the top. They're going to generate higher benefit cost ratios. Okay, next slide, please. So that gets us to sort of the part of how do we program these. And in the beginning, it was decided we were not going to pursue sort of a worst first programming approach. We weren't going to take the highest rated slope and fix that. For instance, if it was on a low ADT facility as compared to something that might be lower rated but on an interstate. So the criteria that we developed and that had been used up until about 2009 was that we were going to focus on interstate and principal arterials with ADTs greater than 6,000 vehicles. We were going to glean from these higher rated slopes, so 350 points and above, and then the other portion that was really critical is they had a benefit cost ratio of 1 or greater. So that got us to about 2009. We've gotten through a lot of projects that were on that first cut of slopes. And since 2009, we've been looking at lower volume facilities down to ADTs of about 1,000. We lowered the risk rating threshold, but still requiring favorable cost benefits. Next slide. So since that time, 1995, we have fixed lots of slopes. We've done a lot of landslide stabilization projects. Oops, can you go back one? Done a lot of scaling work and installed drains and the like. And now we've got lots of constructed assets out there. So next slide. So the question now, after we kind of get towards the end of our program, our anticipated program cycle of this initial 20 years, is how have we done? Have we fixed the problems of the slopes areas that we've identified? Or are we still having deficiencies in terms of these slope-related impacts? So let's talk about expenditures. This graph here shows expenses paid per biennium since 1997, when we started actually building projects, through 2011. The purple bars are program slopes, so you can see we're programming about $20 or $30 million per biennium in that range. And the maroon or burgundy colored ones are these emergent slopes. These are ones that were either not anticipated or developed that weren't captured in the database or didn't program for whatever reason. So that's where what we've spent so far. Next slide. So in terms of those expenditures, we've fixed about maybe close to about 10% of the slopes in our database, so about 250 slopes. These have been fixed either through this programming method or through sort of as an emergent need. Some others come in from other safety or highway improvement type projects, but that's kind of what's gotten done so far. And to date, just through the programming, the program bucket of money, we spent about $180 million. And if we compare the types of problems that we've fixed over this time, we've done about twice as many rockfall mitigation projects as other types of hazards. And the reason for that is generally these unstable slope projects, rockfall in particular, are often less expensive to fix. They have higher benefit costs than landslides in general. So next. So if we kind of reflect on what the performance aspects of what we've done in the last 2 decades, I would say first off is that we really didn't have any sort of metric for performance and management, and we're recognizing that right now. We also recognize that a lot of the service objectives around unstable slopes are not very easily measured. And so if we're looking at, for instance, how well did we do at keeping rocks off the highway, we really need information from our maintenance people to tell us that, and that's something that we are working on trying to improve on. So this is a way for us to improve our sense of measuring these benefits. I put a quote in here from a report that we had commissioned by Golder back in 2005. And they were citing the experience that another geotech had up in BC. We've been working on a similar program for a railroad up there. And the quote is that after 3 decades of stabilization work, it was the opinion that just since inception, that only now, after 3 decades, are benefits being recognized. So the point of this is that this is a long haul, a long vision type of commitment to see benefits in a system like a highway transportation agency. Next. Another sort of new twist that came in 2007 is we were recognizing that a lot of these lower risk but still significant hazard slopes weren't getting into the program. So there was a separate bucket of money, a small bucket of money that was set up just to do rock slope scaling. So that's been funded about $3 million a biennium, and to date we've done about 20 or so slopes. So that's another way to get at some of these slopes that don't program through our standard fully mitigated approach. Okay, next. So kind of the current environment that we're in, we recognize that we need to find and know where all these assets are that we've built. So we're working on that right now, going back through our files. We have a pretty good sense, but not in the way that we really need to manage these. So this asset monitoring that we need to do, we're trying to do some visual assessments of these. We're looking at other sort of tools that we might be able to use, like scanning, LiDAR scanning for maybe monitoring purposes for slopes that we haven't been able to program yet. Could we detect deformation that might trigger some more proactive stabilization work? And then lastly, we're recognizing that we need money to fix a lot of these, or some of these constructed assets that we built now that are 20 years old and are definitely seeing some abuse. Next. So as we look at those, this is a representation maybe of some of the constructed assets attached to a slope management program, like bolts and drapery and cut slopes and the like, and trying to choose out of all these assets which area are we going to focus our assessment on in terms of performance. And we've kind of picked 4 right now that we're talking about focusing on. The first one is horizontal drains, recognizing that those are quite critical in terms of their functionality if they're going to do the things that we need them to do for slope stabilization. Same things for draperies, trying to make sure that those assets are functioning the way they're intended. So I just run through here real quickly some of those things here. So we're using GIS a lot now to try and capture where these things are, how to kind of program these. Next. We're trying to evaluate sort of what elements pose the greatest risk to the facilities. We haven't been as formal as this matrix is represented, but I think it's a goal that we have. Next. We're working with our maintenance folks now to try and develop maintenance procedures around these, and we're just finishing up one for horizontal drains. Next. And then trying to document the maintenance activities that we are doing. That's a really important part in terms of trying to learn from our efforts. Next. So just some photos here. These are a lot of these are draperies and rockfall fences that we've had problems with. These are earlier versions, so we've learned a bit from some of the failures and some of the high load conditions that these have been exposed to. Next. Same thing for rock anchors. We've learned a bit about some of the early deficiencies in our designs that we were incorporating and trying to make changes to those. Next. This is some data on horizontal drains of a system that's been in for 5 or 6 years, where we can see clogging of the drains and increase in piezometric surfaces within the landslide, recognizing that we need to maintain these systems if they're going to function. Next. And then just using some terrestrial laser scanning to look at shotcrete performance and measurement of shotcrete applications. So I'll close here just with these lessons learned. We're seeing that a lot of these lower cost mitigation solutions are being favored over more costly ones. It raises the question, are we fixing the right ones? Are we fixing the most critical ones? And I think that there is some discussion to have about that. We recognize how important GIS has been and needs to be incorporated into an evolving program. And some of the improvements that we're working towards is really trying to capture what we're building and getting better as-built, improving specs and the designs that we're putting out there, trying to improve corrosion protection so we get more performance life out of these systems, and then doing better jobs with our cost estimating, implementing new research projects, and then again trying to find some money to do repair of things that we've built. So thank you.
All right, thanks, Tom. So thanks to all of our speakers today, Scott Anderson, Dave Stanley, Mark Vessely, and then Tom Badger. What we'll do now is open it up for Q&A. I will bring up one last slide here. Maybe not. We'll just go ahead and do the Q&A. So I have computer is not. Here we go. So as you could use on the live meeting feature, there's a Q&A button up at the top. You might see sort of a black or a blank screen right now. I'm just sort of trying to manage these Q&A. So the first question, I just have one so far, is from Shiv Gupta from Wisconsin DOT. And he was wondering if Colorado or Washington State DOT has a database asset management system similar to bridge assets for inspecting, managing, and recording maintenance actions. Question of rock slopes and embankment slopes.
I could take that for Washington. We do not have one formally right now. That is the goal. I don't think I think we're a long way from having something like the what at least our bridge office does. But that is a laudable goal and a goal to work towards for us.
Okay. Scott, did you want to add to that? He specifically mentioned Colorado as well. I'm not sure if you can speak for Colorado DOT. Or...
Well, I'd like to ask if Mark could comment on that. I think he might be more in tune with that than I am.
Sure. Yeah, I can't speak entirely for what CDOT is doing on that. We're doing some project work with them where we are trying to use their maintenance records and some of the other data that are already in their system to help establish what the frequency and the consequence of some of these different events can be, because a lot of them might not even show up. You know, sometimes the rock falls and maintenance kicks it off the road and then we move on, but it might show up in a data record. So there is some work being done on that, but I don't think it's anything that's fully implemented. Scott Richrath, who I think will be leading the next, the phase 2 of this webinar series here in a couple weeks, can probably better answer that specifically to CDOT.
All right, thanks. Next question is, are there any DOTs that have come up with a GeoTech asset manual or a GeoTech asset management manual, a GAM manual?
This is Dave. I think the answer to that's got to be no. We've got some current research just kicking off to have a geotechnical asset management plan created for us, and that's with Paul Thompson. But that's going to be a year or two away. So I think at this point we're not aware of anyone that has a geotechnical asset management plan or a manual. I think the UK has a geotechnical asset management program pretty well developed, but it's I think it's aimed more towards the technical side rather than the management side.
This is Scott. I would agree with what Dave says there.
But I should say that this is Matt from the AASHTO side. We do have a great sort of generic asset management implementation guide if you're interested in that. You know, if you're a member, you can get a discount on that. But every state got 10 copies. So if you're from a state DOT, somewhere in your state DOT, there's a copy of the AASHTO Asset Management Implementation Guide. Next one is from Holly Ellis. It's for Dave. Have you developed weighting factors for the asset categories that feed the health index?
I wish I could answer yes to that, but again, we're just in the beginning parts of this. So we've gotten the recognition that we need to do it, and there is some literature out there about how to aggregate and weight performance measures, and we'll probably be looking at those techniques and adapting them.
All right. Last one that I have for right now is how does Colorado incorporate the other assets such as roadway and culverts into their risk calculations?
So right now there's a project that is underway with CDOT where they're looking at their what they're terming kind of underserved assets. so kind of the non-bridge and pavement. CDOT has managed or does have an inventory and management program for their larger diameter culverts. That actually was an outcome of that failed sinkhole Scott referred to. But as part of this underserved asset category, they're recognizing that other size culverts might be. So there is a risk-based program that's currently in development, should be wrapped up here in another month or two, that at least allows them to do the prioritization to identify those culverts and other features out there that present risk.
I might have to change that. Can you pull one of them up? Yeah, change. Let me just show you.
All right, so we got some background noise there. All right, any other? So that's the last question that I have. I will not say going once, going twice, but if anybody else has any other questions, if you could type them in there, we'll just give you 20 seconds to sort of do that. If we don't see anything, I'm going to start to bring it to a close. I'm going to get one last slide here. All right. One more. Here we go. Has there been any documented effort on moving from qualitative scoring methods toward quantitative performance functions, i.e. movement? I'm not sure, Amir, if the panelists know sort of need some clarification on that or not.
Well, I think one example of that would be there's some efforts to use LIDAR techniques to monitor retaining walls. I suppose that's what he's getting at. And I don't know how well developed that is. I think the techniques are being developed, but as far as incorporating them into an asset management plan, I think that's we're not quite there yet.
And this is Scott. I'm thinking perhaps references also to movement as a metric, some kind of a threshold being set for amount of movement on a slope, be it a rock or a soil or embankment. And the answer to that, from my knowledge, is no.
Okay. All right. Seeing nobody else, I don't see any other questions being typed in at this point. So I'll go ahead and sort of wrap this up for us today. Again, thanks to everybody who participated: Steve Gay, Scott Anderson, Dave Stanley, Mark Vessely, and then Tom Badger. We will somehow make all of these presentations available. We'll probably we haven't gone over this, but I'll probably put them on either the AASHTO Subcommittee on Asset Management website, which is tam.transportation.org. There's a link there called webinars. Within the next week or so, we will post this video so you can view it, and you can share it with your colleagues and your friends and anybody else who's interested in the topic. We'll try to have those presentations available as well. I'm sure all the panelists would be happy to share if you have any more specific questions for them. I'm sure that they'd be happy to, talk with you, offline. If you need their contact information, let me know, or let Steve know, or let Scott know. I'm sure we all have everybody's contact information. I think, and so with that, the last webinar, the second webinar that'll be taking, you should see up on your screen, the one that'll take place on June 24th, also at 2 p.m. Eastern Time. Same phone number, same web address, and everything. We'll have Scott Richrath from Colorado DOT, Ty Ortez, Matt DeMarco, some folks from the Central Federal Lands, Oregon DOT, Utah DOT, and then Ken Fishman. So that'll be the second part of this. And again, don't forget about our bi-monthly AASHTO FHWA webinar series, and then the the Asset Management Implementation Guide book club that meets on a monthly basis. You can go to FHWA's Asset Management website for more information on that. So before closing us out, Steve, do you have anything else to say?
Yeah, I just want to thank the presenters, and I think the examples that were given today really are beneficial as states look at developing the asset management plan. We talked about inventory, condition, targets, doing the economic analysis, risk. I think some of the examples today were some of the best we've seen with regard to risk. And then just bringing it bringing it all together. I think the presentations did a great job of just showing what asset management is and how it can be used and prioritizing how the money's spent. Once again, thank you, everybody. Thank you, Matt.
All right. And then the other, I guess, co-leader of this was Scott Anderson. Did you want to have any last thoughts, last comments?